what is this right here? Look at, it's an if statement that's in the middle of code. Wait, is that valid? Can you even do that? Will this compile? I mean, sure, if you look at it like we're looking at it right now, if you look at the code right here, it actually makes a lot of sense. I understand what it's trying to get at. If we have a temperature, Celsius, where the value of that temperature, T, is greater than 30, then proceed onward. That makes a lot of sense. Does it even work, though? With Rust, they've sort of added more power to the match keyword, the match statement, which is called guards. Now, guards can be used probably in more places. The match is really a good place to use a guard. And apparently, this right here, if you use it like this, an if statement right there in the middle of code will sort of guard or protect against moving forward in that arm of the code. This is called guards in Rust. So let's see if it works. This code right here, this if statement right in the middle of everything. If we run the compiler and run the program, it works. It actually works. Just check it out. That's pretty neat. Powerful, versatile, it gives more capability, and it's also readable. You can read this and understand what's going on. It's pretty clear, pretty clean. Oh, I mean, there's only really one word right? If, very short word, very short. Let's do a quick code walkthrough of this Rust program that demonstrates Rust guards using the match statement. In Rust, you have the capability of using a match statement, but for every arm or sort of like case match, this is like a switch statement in most languages, right? The match statement and a switch statement are very similar. Rust match statement is far more capable, and you can use it to do very interesting things like this if guard, right? This guard right here. So let's walk through the code really quick. This at the very top, we have this. They call it an attribute in Rust that will allow you to disable or enable certain features of the programming language based on annotations of the different whatever you're throwing that attribute above. Now, the allow dead code is something you want to avoid. Most cases, you don't want to have any code that's hanging around that's going to be unused because it's just debt for later on cleanup, right? So you'll be able to tidy your house. This annotation that goes above whatever you're defining allows you to ignore or the linting that usually happens when the Rust compiler checks your code. It will give you a stern warning or even prevent compilation altogether. Using these types of annotations allows the compiler to acknowledge that you very much intend to ignore the compiler in this case. So we have some allow dead code here at the top for the enumerator, which, I don't think we need. Because this code is being used. So we could even eliminate that, and let's see what happens. Yeah, see, it's fine. You didn't even need that line. Well, why is it there? We have an enumeration, which is one of my favorite data structures in Rust. We have two types of options representing temperature, Celsius and Fahrenheit. Both take signed integer 32-bit. You probably doesn't need to be 32-bit because temperatures that go, below 100 degrees, you're entering outer space at that point. And even then, the coldest place on the planet is here on Earth. With our dilution refrigerators, we can get really cold. The coldest temperature ever recorded on Earth is a negative 128.6 degrees Fahrenheit or negative 89.2 Celsius. So we don't need a 32-bit. It's a little bit big. Easily could be an I8, right? Yeah, we're happy with that. All right, so we're going to enter our main function here. We're going to define a temperature at 35 degrees Celsius. Now, I'm thinking that we might want to have a conversion implementation at some point. So we could implement some sort of conversion for temperature, and it returns a new temperature that matches the operator. So we have a conversion in there. We don't need to do that, but at some point that would be nice. Then we're going to use a match statement using our destructuring capabilities, matching on an enumeration of the data type, which is my favorite. This is my favorite pattern. Just this part right here where you got a match and then an enumeration. And then you've got data right here that's associated with the enumeration that you can use in this arm. I love that. Now, what we're looking at here are guards. Guards are the capability to add an if statement right there in the middle that prevent or allow a pass on this arm to execute and to match on that arm. So we can see in Celsius the case, if it's above 30, it will execute this arm. Otherwise, Celsius is equal to or below 30 degrees Celsius. Same with Fahrenheit. We're doing basically the same thing. Okay. Yeah, I see what's going on. It's readable. I don't have to do any weird decoding. All the logic is right there. Very nice, very clean overall. I like this. Here's some Rust code on the screen. Will the code even compile? My guess is, I don't know. Do you think the code will compile? I don't know. I'm looking at it right now, and we can see that we are using a match statement, and we are using some guards here. We're also assigning data on the match, so we have a number that we're matching it against, and then we'll have a variable definition, which we don't need because we're not using it anywhere. So that's one thing right now. We're not using this variable. I mean, we really should use it. That would be nice. Right, let's use that variable. Let's use that data if we're going to be saying there's data there. So if you're reading the code on the screen, you're probably seeing that. I don't know if it's going to compile or not, but it seems like it's hinting at that it won't, and guess what? It doesn't. It doesn't. It says, hey, pattern underscore not covered. Well, what does that even mean? Come on, pattern underscore not covered. Just this statement right here is insanely confusing. I mean, we have to guess what's going on. It says non-exhaustive patterns, which means that your match statement, all match statements, must have to cover the complete domain and capability of whatever you're matching against. For example, a number is a U8, which means it's an unsigned 8-bit integer, so it's between 0 and 255. You must match every single one of those cases. Well, you don't want to have a giant match statement that lists all of these numbers out. That would be insane. You would want to match, however, on a select range, and using a guard like this allows you to do that. Even though we're matching 0 and the rest of it, right? So we're basically matching the whole thing. It says here, matching arms with guards don't count towards exhaustivity. Exhaustivity. Ensure that all possible cases are being handled by adding a match arm with a wildcard pattern or an explicit pattern. And everyone knows that an underscore is the wildcard pattern. No, nope. In Rust, it's not really that it's an underscore. It's just that you need to have any data here. It could even just be I, right? And then underscore, anything that starts with an underscore, including another underscore, is going to count as ignoring the data if it's not used. Otherwise, the compiler will complain. So we do want to have that matching statement here. I would say go like this. That should compile now, right? It's going to compile. Yep. Okay. Now we're good. Oh, wait, hold on. There's something interesting happening here that no one's told us before about. There's this thing called unreachable exclamation point. Oh, this feels very annoying. So we'd never need an actual variable there. We'd never need a print variable, and it will never happen. I can see why this is actually really necessary and meaningful in code. You will have this unreachable macro here with the exclamation point saying that this should never happen, because if it does happen and you intend it to never happen, the compiler will be able to catch it, or the runtime will throw an error. So taking a look here, for example, there's some statements here that should say unreachable, and a compile error will occur if we don't include this. So this is actually a pretty neat pattern. I've never used this pattern before. However, I think it's actually pretty meaningful, because under many conditions, you've got these algorithms where the code will never reach a certain point through your intention. You intend it to never be reached. So it's best if you actually add your intentions and you know that that's supposed to be the case, because it will help protect your code in the future. So it's actually a nice little protection that's built in to Rust. Actually really neat. Although it's very annoying. Under this case, I don't want to have to do that. And you know what? I think there's good news. There's actually a way to do it using some interesting syntax that we will check out a little later.